Can you solve this problem? Let's call these equations 1 and 2 respectively. Well, first, note that these two numbers, they are real numbers. The question is, are x and y real numbers as well? Well, let's see. From this first equation, let's write y as a function of x. So y is 4 minus x. And let's use this result into the second equation and obtain x, which multiplies 4 minus x equals 24. So 4x minus x squared subtracted by 24 equals 0. Let's rewrite this equation as x squared minus 4x plus 24 equals 0. This is a quadratic equation, and we know how to solve it. So let's call the coefficients of these terms as a, b, and c. So a is 1, b is minus 4, and c is 24. So x is equal to 4 plus minus the square root of 16 subtracted by 4 times 1 times 24, which is 96, over 2a, which is 2. So inside the square root we obtain minus 80. And we know how to deal with the square root of negative numbers. This is the same as the square root of minus 1 times the square root of 80. The square root of minus 1, we know that it is I. And let's factorize 80 as 16 times 5. Because 16, we can write it as 4 outside the square root, 4, and it will multiply the square root of 5. Okay, now we can simplify that and write 2 plus minus 2 times I times the square root of 5. And you can factorize 2, which multiplies 1 plus minus I, the square root of 5. So these are the two values, the two possible values for x. What are the possible values for y, the corresponding values for y? Y is 4 subtracted by x. So it is 4 minus 2 minus plus 2 times I times square root of 5. And that is 2. The real part is 2. And let's factorize it in such a way that it will multiply 1 minus plus I in the square root of 5. So these are the solutions. But let's write it in another way. Let's call the upper solutions, the upper sign solutions, as the index 1. So x1 and the corresponding y is y1 is 2 plus 2 times square root of 5 times I, and the corresponding y is 2 minus 2 square root of 5i. And the lower solutions are x2 and y2 with these signs. Okay, we can see that there is a symmetry between x and y due to the symmetric nature of these two equations here. Now, let's do the verifications. First, x plus y. This is x. We will do both solutions at the same time. This is x, and let's sum y, which is this one. The result is 2 plus 2, the real part, and the imaginary part, they will cancel out. The upper sign plus with this factor and the negative of the same factor, and for the lower case, the negative here and the positive solution, the positive factor here, resulting in 4, verifying the first equation. The second equation, x times y. So this is x, and let's multiply it by y. 2 by 2 is 4. So the first term, 1 multiplying 1 is 1. The crossed terms will cancel out. For instance, 1 times this factor plus this factor times 1, they will cancel out. In both cases, for the upper and lower sign solutions. And when we multiply this term by this one, we will get I squared times 5. I squared is negative 1. So we get as a solution minus 5. And for the upper solution, we get another negative sign here. And for the lower solution, a negative sign as well. So the result is positive 5. So we get here 6 times 4 equals 24, verifying the second solutions. Indeed, 4 and 24 are real numbers, but x and y are complex numbers. Thank you.